resolution of vectors. But before that, I request you, if you haven't covered the video of law of parallelogram, I request you to see that first and then move on to resolution of vectors. And I request you to do like, share and subscribe my channel, and don't forget to click on the bell icon for further notification of my videos. Thank you friends. So let's get started. Resolution of vectors. A vector can be represented by summation of two or more vectors. एक example ले लेते हैं. For example, vector v, I write it as v1 alpha vector plus v2 beta vector plus v3 gamma vector. So this alpha, beta and gamma are nothing but unit vectors. And v1, v2 and v3 are components of vector v. So in this way we can split a vector. So the process of splitting a vector to two or many components is nothing but resolution of vectors. मतलब एक वेक्टर को दो स्प्लिट कर दो, उसके टुकड़े कर दो, यानी वो जो एक सिंगल वेक्टर इफेक्ट देगा वो समेशन ऑफ अदर वेक्टर्स देगी, उसे बोलेंगे resolution of vectors. Now let's take an example and understand it in a better way. So here I take a coordinate system x and y. This is x-axis, this is y-axis, and this is my resultant vector r. So this I take point as C, here it is origin O. So this r vector should be split into two vectors. So I draw perpendicular from vector C on x-axis and on y-axis in this way. So I get here two vectors. One is rx and the other one is ry. So this ox is nothing but rx vector and oy is nothing but, now let's represent it as a and b rather than ox and oy. So here OA is rx and OB is vector ry and OC is vector r. So by law of parallelogram, I write it as vector r is nothing but vector rx plus vector ry. So if the components of a resultant vector are mutually perpendicular to each other, म्यूचुअली परपेंडिकुलर यानी 90 डिग्री बनाते हैं कंपोनेंट्स एक दूसरे से. सपोज these two vectors are creating 90 degree, right? Here these two vectors creating 90 degree. So these two vectors, if they are mutually perpendicular to each other, then they are known as rectangular components. What they are known as? Rectangular components, right? And here the angle formed with component and vector's component, it would be theta. Now let's find cos theta. As you all know, cos theta is nothing but adjacent side upon hypotenuse. So what is adjacent side for this theta? Rx. And what is hypotenuse for it? R. So I write it as Rx upon R, right? So my Rx would be R cos theta if I transfer this R to this side. So this is my equation number 1. Then I try to find sin theta. Sin theta is nothing but opposite side upon hypotenuse. So here for this theta, opposite is here, and as this is a rectangle and these are rectangular components, so this would be equal to this. So here also I have ry. So here my opposite would be ry upon r. So now when I try to find equation when I shift it to LHS. So here r into sine theta equal to ry. This is equation 2. Now I combine these two equations and square. Adding and squaring equation 1 and 2. Now when I add it, suppose this is LHS side. I rewrite it as ry is equal to r sine theta. And now I add it. So it would be rx square plus ry square. That is LHS और LHS add हो गए. उसके बाद equal to ये और ये add हो गए. मतलब r square sin square theta plus r square cos square theta. Right? Then this r square and r square can be taken as common. So ये r square common ले लूं तो मेरे पास बचेगा sin square theta plus cos square theta. And it is been proved that sin square theta plus cos square theta is 1. So we are not going to its proof. This is just a formula which you need to remember, that sin square theta plus cos square theta is equal to 1. So here I get r square and here it is rx square plus ry square. Then if I simplify it further, what I get is, so now what we have with us is r square is equal to rx square plus ry square. If I shift the square to this side, it would be under root. So magnitude of vector r is nothing but under root of rx square plus ry square. So this is how we derive formula to obtain magnitude of resultant vector r, that is under root of rx square plus ry square. If I take 3D, that is three-dimensional Cartesian system, if I take 3D Cartesian system, then my r would be rx square plus ry square plus rz square. If I take 3D Cartesian system. Now how to find direction of this vector? Now we need to find direction of this vector, right? So we take tan theta. So what is tan theta? Is opposite upon adjacent. Now here for this theta, opposite is here, so which is nothing but ry. So I get ry upon adjacent is rx. So here I get rx. So if I want to find direction, then I need to find theta, right? So theta would be, when I shift this tan here, it would be tan inverse ry by rx. So this is a formula by which we can find direction of an vector. मतलब ये theta से direction कैसे मिलता है? Suppose if my angle theta is 30, then I'll take 30 from x-axis and draw a vector which says that my vector is in first quadrant. But if I say that my theta is 120 degree, so this 120 degree will lie in this quadrant, right? So it will say that my direction is here in this way, right? So this is how theta helps to find direction of an vector, right? So this is what we covered. First we saw what do you mean by resolution of vectors. So resolution of vector is nothing but splitting of a vector into two or more components. If components are mutually perpendicular to each other in this way, then they are said to be rectangular components, right? Then we saw that how to derive formula for calculating magnitude of resultant vector. So the formula came out to be r is equal to under root of rx square plus ry square. Then to find direction, we need to find theta. So we here took tan theta. The formula for tan theta is nothing but opposite So I got theta is equal to tan inverse of Ry upon Rx. In upcoming video, we will cover the rest part. Keep watching and have a safe day, guys.